Welcome back viewers. In today's video we are going to discuss about reproducible software systems. So let us start. First of all, what is reproducibility? For the findings of a study to be reproducible means that the results obtained by the experiment or an observation study or in a statistical analysis of a data set should be achieved again with a high degree of reliability when the study is replicated. So a thing which can be observed again and again, which can be reproduced again and again is called reproducibility. And there should be a high degree of reliability between the different occasions when the same data set can be reproduced again and again. Replicability and repeatability are related terms broadly or loosely synonymous with reproducibility. So now we will go ahead. So any reproducible system, any reproducibility event is loosely or broadly connected or synonymous with replicability and the repeatability. So a reproducible event, a reproducible data set repeats or it can be replicated again and again. Reproducibility in software systems. We use a concept of reproducible builds also known as deterministic compilation. It is a process of compiling software which ensures that the resulting binary code can be reproduced. Source code compiled using a deterministic compilation will always output the same binary. So during each of the compilation process, same software binary code can be reproduced again and again. Reproducible builds, also known as deterministic builds, ensure a byte for byte equivalent binary given identical source code. Reproducible builds make it possible for anyone to reproduce the build process and gain improved confidence that the software package is exactly what the developer intended it to be. So what will happen is if you keep the source code same and compile it again and again, it will result in the binary code that is byte for byte comparable during each of the compilation. So if you compile it 100 times, each time the compile code will behave in the same fashion, it will have the same feature set, and we will understand that the developer had intended to compile the code or wanted the resultant compiled code to be same, and that he is successful in getting what he wanted out from the source code. Now you can understand this better in a diagram. So suppose this is some source code is input. This box in the middle contains the toolchain, that is the compilation toolchain or build toolchain and processes, along with some quality assurance applied to the process and the toolchain. So what happens is when you input the same source code again and again, it will always give same output again and again. So the same package or the same system will be built again and again. So the performance, the feature sets of the build system or package will be same every time it is built again. So this is how it works. Further, I want to tell you that this build toolchain and process with the quality assurance has to be in turn reproducible. So the toolchain should behave always in a same fashion. So if there is some change in the toolchain or the process, or if there is a change in the quality assurance process, then the same source code might not compile into the same system package or build or the same target that the developer wanted. So there might be some variation. I think you understood. We can go in lot of depth, but then the video will become very long. 2 hours, 3 hours also can be taken for such a video. So I will keep it short. I will leave some links in the video description that you can open and read on your system, so you will get a better idea. Now, what are the advantages of reproducibility in software systems? First, it ensures the delivery of targeted software feature set. It ensures bugs are kept out. No new bugs creep in during the build process. Now what happens is, suppose the source code keeps changing or the toolchain keeps changing or the quality assurance and the processes applied for building the source code changes, then it might result that some new bugs are added to the what we can say compiled compiled packages or the system. So what happens is there will be some variation between the different builds. So that can introduce certain bugs, that can introduce certain unwanted behavior in the package build or the package system. It ensures that no malicious code injection is there. Suppose somehow the developer system is compromised, there is some hacker and he introduces the malicious code inside the source code. Then what will happen is when you go for a reproducibility in the compilation process or the development process, immediately we can figure out that there is some difference in the feature set, some difference in the targeted software feature set. It can be easily found out, and then the malicious code can be removed. So it is very good for ensuring that no malicious code is injected into the source code, and it doesn't find its way to the package build or the package systems. It reduces the burden on quality assurance team. So what happens is when the source code remains same, your toolchain, your build processes and the quality assurance remains the same. It reduces the burden. So we know what we are inputting into the build processes and what is the output. So everything is known, well known. So the quality assurance team knows what is the targeted software feature set and what is the source code. So they know exactly what will be the output. And if there is some variance in the output, you can easily troubleshoot and find out what is causing the variance in the targeted feature set or the behavior of the compiled code, compiled packages or the compiled system. So you can easily find out the malicious code and remove it. Now there are some advances in the software systems reproducibility. The core infrastructure initiative CII has been quietly working to prevent an even more insidious form of backdoor, that is the malicious code inserted during the software build process without the developers' knowledge or consent. Such attacks are by no means theoretical. Documents from Snowden's Trove make it clear that the malicious actors, hackers, and intelligence services are actively working to compromise the software build process on individual developers' computers. In an effort to help the open source software developers build more secure software, the Linux Foundation is doubling down on its efforts to help the reproducible builds projects. Among the most basic and often most difficult aspects of software development is making sure that the software end users get is the same software that the developers actually build. Now, achieving a completely reproducible OS is a very difficult task. Developers are aiming at 100% reproducible packages and system configs. Here, the Debian project is leading along with the different Linux distros and software projects, including the Tor browser and Bitcoin, and they are working to make their build processes more trustworthy. And the CII has thrown its financial weight behind the project. Debian has achieved over 91% reproducible packages in unstable repos of Debian, that is the unstable branch of the Debian. NixOS builds packages in isolation from each other. This ensures that they are reproducible and don't have any undeclared dependencies. So if a package works on one machine, it also will work on the another machine. In NixOS, 1733 out of the 1737, that is the 99.77% of paths in the NixOS ISO minimal 32 or 32 as well as 64-bit Linux installation image are reproducible. Plus, Nix packages are also 100% reproducible. Nix is the package manager of NixOS. So, all the packages in the NixOS are 100% reproducible. Notable Linux distributions and software vendors working on reproducibility are Arch Linux, Alpine Linux, Baserock, Apache Maven, Buildroot, Core Boot, ElectroBSD, FreeBSD, Fedora, Guix Linux, NetBSD, MirageOS, OpenSUSE, OpenEmbedded, etc. So with this, I will stop the video here, and from the next video, we will start looking at the Nix OS. So the Nix OS project is one of the best Linux projects going on, and we should take a look at the Nix OS project and the different technicalities in the Nix OS project along with the two live images available in the NixOS for the desktop users. So see you in the next video. Bye.